which is a 4-hour round trip from Berkeley. And undergrads generally don't have a car and can't rent a car, so the fact that we now have these remote facilities available makes it a very, very useful telescope for students. Yes, Will? Do you count as undergraduates?
No.
You don't count as undergraduates yet because you have to have graduated from high school. But I do occasionally have high school students in my research group. So I guess to be complete, I should say undergraduates and occasional high school students. So the galaxies we typically look at are hundreds of millions of light years away with this telescope, billions of light years away with the bigger Keck telescopes. Now you can see the mirror, you can see the shiny surface. In fact, you can see the reflection of my laser pointer up on the dome shutters there. See that?
Are they going to open it?
They might open it, yeah. Once it's pointing farther away so that, well, when you open the telescope dome, debris can fall, and so we try to point the thing away. So every star has the equivalent of a latitude and a longitude in the sky. You set the latitude by where the telescope has swung in its horseshoe shape. And you can't have any bubbles and you can't have other imperfections. And so they wanted to test this on a 120-inch mirror before they let loose the process on a big, expensive 200-inch mirror. So this was, in a sense, the leftover of the creation of the Palomar-Hale 5-meter telescope. And that helped us a great amount. The biggest telescope that had been built up until that time was the Mount Wilson Observatory 100-inch so-called Hooker telescope.
What created
Suddenly, what looked like the near side is suddenly the far side, and yeah, so we're rotating, but
We're moving.
it's a small enough motion, and in particular a small enough acceleration, that it's really very difficult for us to tell. Yeah.